Hello. Hi, guys.
Hi. Hello.
So, do you want to ask me about anything at the beginning of our today's class? Not really?
No.
Okay. In this case, I will start my class in the regular way. So I will definitely find right now time to check attendance, and beside that, we will be solving problems. So I discovered quite interesting problem here on page number 443. This is the problem. Actually, this is in the part of the last problems for section 11.1. So I'm going to right now talk about this problem, and I would really like to ask you to actively participate in the process, at least in the last 2 days of our class. Try to even a little bit to bring your class participation higher. Excellent. Result can be reached if you do this kind of things. Okay, this is the problem on page number again 443 from section 11.1, and number of this problem is 57. 57. Let me grab a piece of paper. Do you need any kind of feedback for problem number 43, which was the last one, which was solved yesterday?
No.
Can I remove it?
Yeah.
Okay. I don't have space there anymore. So again, I am declaring problem number 57, page 443. And I'm going to read this problem right now. Actually, I will be reading and writing on my paper at the same time. Let f at x be 16x to the 4th. This is just one of regular power functions. It is not an exponential function, because sometimes people can be confused thinking that if it has certain power, it is an exponential function. No, it is a power function, because in exponential function, your independent variable should be at the exponent. Here, and your independent variable works as a base of that power. So, and what should we do here? So we have two functions. One is f at x, and second is g x, which is 4x squared. So two power functions. Two power functions. And we have here two separate parts, part A and part B. What do we have in part A? If f at x equals g composed with h at x, so which means if we can treat f at x as a composition of two other functions, g function and h function. Find a possible formula for h at x, assuming, what should we assume? Assuming that h at x is less or equal to 0 for all x. How can I write for all x? I'm just writing, instead of letters, all math symbols. This how I wrote it down. F at x equals to the composition of g by h function. We need to find the formula for h at x, assuming that h at x is not positive for all x's from set R. Because for these functions, we do not use complex numbers for x values. We are just limited to set R. Did you understand the conditions here?
Yes.
Okay, what do we do here? We are treating this time f at x as a result of the composition of two functions. Okay, let's actually start the process. G at x has its given formula. So G at x equals 4x squared. It is given. Then I can use this to simplify this composition. Can I write, and I'm going to show this to you right now. Can I write that because g at x is 4x squared, using that formula, I show here a simplification for this composition. Inside piece in this composition or interior function is h at x. According to the formula for g at x, what should I do? Everything what I had in parentheses next to g symbol, I need to raise to the second power and multiply result of that power by 4. This why I'm doing that now. Inside, after g, I have h at x. I need to square it and multiply by 4. So far, so good?
Yeah. Yes.
Yeah.
Comparing this with f at x, I can conclude that it means that 4 times h at x squared should be, look what I'm saying should be equal to f at x, which is 16x to the 4th power. All right?
Yeah.
Now I'm going just to treat this last statement as a regular equation. Can we divide both sides by 4?
Yes.
Yeah.
To get rid of that 4 in front of h squared, right?
Yeah.
So we are getting h at x squared equals 4x to the 4th power. Agree?
Yes.
Yeah.
But I don't need h squared. I'm looking for the formula for h at x. Should I take square root from both sides?
Yes. Yes.
Okay. Usually, when we take square root from both sides, solving equations, we need to keep in our mind that we can use plus minus sign, right? For the root.
Yes.
But here it will not be a case because we have a condition, which I'm going to box right now, that for all x's from set R, h at x or negative or 0. Do you understand that?
Yes.
Yes.
Because of the condition, considering that situation, I can come to the conclusion that h at x should be equal to negative value of this root. Do you agree with me?
Yes.
Yes.
And what would be the value of that root? 4x squared, 4x to the 4 is a product of 4 by this power. The square root or any root of that product is equal to the product of roots of factors of that product. So it will be square root of 4, which is 2, square root of x to the 4. X to the 4, is it the second power of square?
Yes.
Yes.
What would be the square root? Is it x squared?
Yes.
Yes.
Yeah.
And voila, magic, but we have a box which has a formula for h at x. It is equal to negative 2x to the second power. Did it click?
Yes.
Yes.
Do you want to ask any additional question about this part A?
No.
No, it's all
Are
right.
you completely satisfied? You understood every single step?
Yeah.
Can I move to part B?
Yes. Yes.
Yes, please.
What I see here, part B, is honestly much more challenging than part A. But we are not afraid. We are all together, right? We are one team. We will survive. Okay, I'm reading. If, and writing at the same time, if, so part B, if f at x equals, now it is another composition. We are seeing another function j of what? 2g at x. Okay. Find a possible formula for j at x. J at x, assuming j at x is a power function. F at x is a composition of j by 2 times gx. We need to find the formula for j at x, assuming that it should be another power function. Are you with me?
Yeah.
Yeah.
Let's start. We know that f at x has new representation using now new composition. Is it true? Yes?
Yes.
Yes.
In that given part, can we replace, let's say, f at x by its formula, which was given in this problem?
Yes.
Is it 16x to the fourth power?
Yes.
Okay, write it down. 16x to the fourth equals, so it is actually equals to what? J composed with 2g of x. And I start my simplification. What about gx part inside of this parenthesis of that composition? Do we know the formula for gx? Was it given also?
Yes.
Was it 4x squared?
Yes.
Can we replace that gx by 4x squared?
Yes.
Yes.
Okay. 16x to the 4 j parenthesis 2 times 4x squared. This is not a composition inside of parentheses. This is a simple product of 2 and 4x squared. If we multiply, do we get ax squared?
Yes.
Then 16x to the 4th equals j composed with what? 8x squared. Right?
Yes.
But when we started solving part B, we had another given part. Now we need to apply this part of the given. It sounds ridiculous. This part of given part. Do we know that, in other words, j at x should be a power function?
Yeah.
So which means I need to recall the general standard formula for the power function. This why here on this side, I can write that j of x equals actually k, coefficient k, times x to the p power. Can I? Guys?
Yes.
Okay. So, and what do we get here? Because here we have the same thing for the 16. I'm talking about that like a general approach. These are formulas for power functions. This why, what can I write here? Can I say the same thing about f at x, that it can be written in the same way using that general formula? I'm talking about f at x.
Yeah.
All right. So in this case, look what I'm going to do. So we are just assuming that both formulas, again, definitely can be written in that way. And I'm going to write this about f at x. F at x, I reminded you just formula for j at x and g at x and f at x and all power functions. They can be written like k times x to the p power. Okay. This is what I'm starting, actually solution. Now, the next step of solution. I wrote it down, and now, what do I have here? F at x, is it now equal j of what I have in parentheses 8x squared? Ladies and gentlemen.
Yes.
Yes.
Okay. In this case, I can assume that f at 8x squared equals k 8x squared to the p power. Right?
Yes.
Yes. Yeah.
Let's simplify this part. K is standing in front of this parenthesis, right?
Yes.
What about that piece inside of parenthesis, a squared? Should I raise this to the p power? Is it actually product to the power?
Yes.
Yes.
Can I separately raise to this power 8 and that x squared?
Yes.
Yes.
If I have x squared to the p power, is it x to the 2p?
Yes.
Yes.
Simplify. K, 8 to the p times x to the 2p as a power. But I know that my f at x was 16x squared, right?
Yes.
So which means I'm getting 16x to the 4 equals k times 8 to the p power times x to the 2p. Agree?
Yes.
And now I'm comparing the left side and the right side. What do I have on the left? I have 16 as a coefficient times x to the 4. On the other side, I have k times 8 to the p times x to the 2p as a power. In this case, if I have the equal sign between left side and the right side, can I assume that coefficient on the left should be equal to the coefficient on the right, and that power part should be equal to another power?
Yes.
Yes.
What is the coefficient on the right? I united these two pieces to show that this is your new coefficient. This is your coefficient. So which means k times 8 to the p. I'm going to write this separately. So 16 equals to k times 8 to the p. It is one thing. Second, x to the 4th power equals to x to the 2p as a power. Can I? I can even box that, these two, because this is quite important conclusion. Can I?
Yes.
Yes.
And let's say first find that p value, because second piece is easier because it is x to the 4 equals x to the 2p. The other one has k like an unknown, it has p. So I'm going to use the second part. I don't have enough space, so I will squeeze a little bit. If it is too squeezed, tell me. So which means I'm going to write right now x to the 4 in other form of x to the 2p. Can I write that this is actually like x to the 4 equals to x to the 2p, means two powers are equal to each other. They are sharing the same basis, x here, x here. It means that exponent should be equal to the other exponent. Guys,
Yes.
x to the 4th equals to x to the 2p. In these powers, do we share same basis, x here, x here?
Yes.
Are they equal to
Yes.
each other?
Yes.
Yes.
That means that exponent on the left should be equal to the exponent on the right,
Yes.
Yes.
which means, look what we are getting. P is equal to 2, and I am even boxing that. Very simple conclusion. We found that P value, P is equal to 2. Now, being equipped by this P, I can use it in the other statement that 16 is equal to K times 8 to the P. So I am getting 16 equals K times 8 squared. Can I?
Yes.
8 squared, is it 64?
Yes.
Yes.
So 16 equals to 64 times k. And my goal is to find the value of k. Can I divide both sides by 64?
Yes.
Divide by 60 for both sides. 16 over 64. 64, is it divisible by 16?
Yeah.
Then what do you get?
1/4.
1/4.
This is your missing value for k. K is equal to 1/4. Now, if I know the k value and I know the p value, can I write down the formula for j at x? Because we know that it should be coefficient times x to the certain power.
Yes.
So what is the coefficient?
1/4.
1/4. What is the p value? Is it 2?
2. Yes.
That's it. We have the answer for part B. J at x is equal to 1/4 of x squared. I'm done. Do you agree with me that part B is more challenging than part A?
Yes.
Yes.
Did you understand all steps?
Yes.
Just one person?
Yes.
Yes, you mean one person, or you are also? Okay. Guys, again, critically look at what we just solved. And if you need any feedback, tell me please about that. Because I will be moving to another problem right now. What should I do?
We can move on.
Move on.
Okay, let's see what we can do. We are going to jump to another spot. We already had something here, but we can solve more. I'm up back to page 461. Yesterday, we already solved some problems from 461. I do not have any space left on this paper. Is it okay if I grab another piece of paper? I don't, this is an evidence, no space anymore here. Can I remove this
That's fine.
paper?
Yes.
Yes.
Okay. So we have quite interesting, actually, problems here. And this I'm going to read. In exercises from 13 through 16, using what you know about the long-run behavior of a rational function, match the function to one of the graphs in figures 1 through 4. Explain your reasoning. Explain your reasoning. Okay, let's try. But I will let you choose your own problem because I'm not going to solve all these 4 problems here. Do you have problems on the back? Here, no, this is different spot. But you have your problems from 13 through 16. Which one do you want to work with right now? Choose one of problems.
14.
Okay, number 14. Page 461, problem number 14. I'm going to copy. Okay, y is fractional line x minus 1 and bottom part x plus 3 x minus 2. This is the formula for that. particular function. Are you with me?
Yeah.
Yes.
Let's start. Anytime when you need to say anything about any function, first step is domain. Domain is the required first question. What about this particular function? Does it look like a power function to you? Answer is no. Does it look like a linear function to you? Guys, can you please reply to my questions?
No, it's not.
No. Does it look like a quadratic function?
Yes.
Yes.
No. Does it look like a rational function?
Yes.
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 And rational functions extremely rarely have domains equal to set R. You immediately look to, you should concentrate on denominator, and you have to exclude values. For this case, again, I'm so happy that denominator is already factored, because if it is not factored, usually in these cases, we try to factor the bottom of that fraction, but it is already factored. What do? X plus 3 is not 0. X is not equal to -3. X minus 2 is not 0. X is not equal to 2. I discovered two bad numbers and excluded them. So which means here, I can already write down that domain of that function is set R except -3 and +2. If you do not want to write this in that kind of set notation, we have here 4 different notations, but 2 are better than others. So I like a lot, let's say, set notation, but you can write this in interval notation from -infinity to -3, united with -3, 2, united with 2, positive. It is more detailed, but it is much longer. This what you can write. I like the first one better, but if you like the second one better, it is perfectly legal. And now I'm going to look at these problems. First of all, I will immediately exclude graph number 4. It cannot match that formula, because if you look precisely at number 4 graph, domain is set R, and this why it is not going to work here. I am absolutely sure. It cannot match number 13. Problem for number 13, it is another problem. There is also set R, and in the graph number 3, also domain is set R. So which means we are narrowing our search. We excluded from our search already graph with number 3 option and graph number 4 option. Why? Because they both have domains equal to set R, all real numbers. So we now have in our possession graph number 1 and graph number 2. And both actually have some kind of asymptotes and etc. And this looks very realistic, because if we look at 2 bad numbers, I'm already quite having some ideas that probably I should have here 2 vertical asymptotes passing through x equal to -1 has equation x equal to -3 passing through x equal to -3, and the other one, x equal to +2, passing through x equals to 2. But they did not ask here about asymptotes. They are asking here us about here long run behavior. Excellent. I am going to do limit x is approaching positive infinity of y, so it will be limit x approaching positive infinity of that fraction x minus 1, x plus 3, x minus 2. And I'm going to find this limit right now. Let's start. Do we have here any uncertainty, dear ladies and gentlemen? Pretend that you are plugging instead of x positive infinity. Do you get infinity minus 1, which is infinity on the top?
Yes.
Yes.
In each of these parentheses, do you get infinity here and infinity here?
Yes.
Yes.
Is it infinity squared? But infinity squared is infinity. Is it that type of infinity, like infinity over infinity?
Yes.
What do we do in these cases?
We divide by the highest power,
Perfect. What is the highest power here?
x squared.
Can we divide top and the bottom by x squared?
Yes.
Let's do that. And we already did that kind of trick. You don't need even to drop parentheses downstairs. You can split x squared into separate two x's and divide each of these parentheses each by x. Is it what we get?
Yes.
And now let's analyze each part. So what do you have here on the top? You again divided both by, again, please check carefully what you have. So on the top, you have 1 over x. What would be the limit of 1 over x?
0.
Write it down. What would be the limit of 1 minus x squared when x is approaching? Is it another 0?
Yes.
But I can say, oh, 0 minus 0 is 0, 0. But I need to see what I have downstairs. Let's continue. In first parenthesis, 1 is 1. Limit of 1 is 1. What about limit of 3 over x?
Also 0.
Right. What about limit of the second part? Is it 1 minus 0
0.
as well here?
Yes.
Yeah.
So we have 1 actually in the first parenthesis, 1. Is it 1 on the
Yes.
bottom?
Yes.
Is it like 0 over 1?
Yes.
Yes.
So it is 0. Conclusion, we have here a horizontal asymptote which has an equation y equals 0, because if you are looking for long run behavior, you are searching if you are having this limit equal to the fixed number, not like some kind of infinities, no, fixed number. Y equal to that number is your horizontal asymptote. I already know I have here a horizontal asymptote, which is y equal to 0. I will immediately, quickly, in the same manner, and this time I will be much faster, do x approaching negative infinity. In the same way, only please, instead of x approaching positive, write minus infinity. But steps are the same. We have an uncertainty. Doesn't matter if we have positive infinities on the top, on the bottom, we are doing the same type of work. X squared is the highest power, dividing top and the bottom. So basically you are repeating all these steps before you drop your limit sign. Don't forget to carry that limit sign when you still have x's in the problem, because if you accidentally forget, it is a mistake. Okay, so far I copied these all steps. And now I will be thinking about each of these limits of each of these pieces.
Professor, I got a question.
Yeah.
Why did you, for the bottom part, did you divide by x squared?
I did, but I split x squared into x times x and separately divided each of these parentheses by x. If I divide first parenthesis by x and second parenthesis by x, does it mean that finally I divide the bottom part by x squared?
Yeah.
Or if you do not want to do that, drop parentheses, FOIL, and you will be having a quadratic trinomial with x squared in it, and divide each of these three terms by x squared separately. It is another option.
Oh, okay.
Also legal. I just wanted not to spend too much energy. This is why I became a little bit lazier and split this x into x and divided each parenthesis by x. Did it click?
Yeah.
Let's look at the top. Don't forget, x is approaching negative infinity. In this case, what would be your limit for 1 over x? Is it 0?
0.
Yeah.
But look what I wrote. I wrote negative 0. 0 is not negative, non-positive, but we use this symbol, which means, yeah, this is the limit, but it is reached from the left, because here x is in the first power, and it x approaching negative infinity, it means it stays negative. Do you understand what I'm talking about?
Yeah.
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 Why I wrote 0 with this minus. Limit is 0, but it is 0 reached from the left. But in the second part, do we have x squared? Right? If x is approaching negative infinity with this square, x squared will be approaching positive infinity. In this case, it will be positive 0, right?
Yes.
Yeah.
Right.
That negative 0, positive 0 is 0. So practically on the top, I have again 0. Let's move to the bottom part. What do I have here? In each of these, I have x in the first power parenthesis, right? So positive 3 over negative will be negative number. So on the bottom, in the first parenthesis, I have negative 0. But when we have negative 2 over negative, it will be 1 here minus negative 0. It sounds funny, but this is the case. We are just talking about how these limits were reached, from left side or the right side. But 0 is neutral, not positive, not negative. So basically on the bottom, I also have 1. So does it mean that actually we are talking about same asymptote, y equal to 0?
Yes.
Yes.
Y equals to 0 is an official equation of the x-axis, because y-axis has official equation of x equal to 0, because all points on y-axis have x equal to 0. An official equation of the horizontal axis, x-axis, is y equal to 0. Can we write here, please write this as a sentence, that actually the graph should have an x-axis as a horizontal asymptote? Guys,
Yeah.
can you now look at graph number 1 and graph number 2? To your opinion, which of these graphs has horizontal asymptote as x-axis?
1.
1.
You got that? Yes, our choice is graph number 1. Write it down. That graph number 1 here actually represents the graph of that function in number 14. That's it. graph number 1 is our option. I did not write a sentence, I just wrote down graph number 1. Do you understand how to talk about that?
Yeah.
So having our graphs, we can look at their behavior, how they are located on that XY coordinate plane, and according to that, we can find so-called possible formula for that graph. If we have already equation, definitely we can analyze properties of that equations, and according to that properties, we can build possible graph. Or if the graphs are given several versions of graphs, according to that properties, we can choose that graph which actually matches these properties. Do you understand what I'm talking about?
Yes.
Yeah.
Okay. This why, again, it is really so important to do the work. I have a little bit time, and I like to demonstrate as I can do in allowable time for us to finish our lecture. This is why I constantly look at my watch, how much time is left. I will start. If I do not finish this right now today, I will start my next class with that problem finishing. Are you okay with that?
Yeah.
That's
Yeah.
fine.
Let's say
Yeah.
this time we have more like traditional form of the problem. We will have the problem where function will be given. Let's say y equals 1 over x squared plus 5x plus 6. Typical rational function. And we need to build the graph of that function. And this is the formula. First, I recognize the function. It is a rational function. And I'm starting. First step, I will try to factor the denominator. Y equals 1 on the top. X squared plus 5x plus 6 is a quadratic trinomial. Leading coefficient is equal to 1. They are quite easy. I'm just looking at the last number, which is 6. How can you factor 6? That adding numbers, you can get 5. What about these numbers? Are they 2 and 3?
Yes.
Yeah.
So which means it will be x plus 2, x plus 3. And voila, I have a factored form. But now I will exclude that values. Can I write that x should not be equal to 0, so x cannot be equal to -2? And x plus 3 is not 0, so x is not equal to -3.
Yeah.
Right?
Mhm.
Yes.
Which means I have 2 excluded values. I will be ready to write something about domain. Is it okay if I write just one version of domain?
That's fine.
Yeah.
You can list bad numbers in different sequence. So I decided to start with the smaller number followed by the greater number. So R except -3, -2. What can I see again from what so far I have? Y is a fraction. On the top, I have constant 1. I don't have any x's on the top. Can we solve the, look, let's say I'm calling this part 1 about domain. Second, x-intercepts possible. So x-intercepts are the numbers for which x is equal to some number, y should be equal to 0. Do you agree with me if we talk about x-intercepts for this function?
Yeah.
So
Yes.
which means, what should I do here to find x-intercept? I need to make y equal to 0 and solve it for x. So which means I'm using that equation, which is x plus 3x plus 2 downstairs equal to 0. This is the fraction equals to 0. But fraction can be equal to 0 only if I have on the top something what can be equal to 0. But on the top, I have number 1. 1 is not 0. Can I assume that that kind of x value does not exist actually?
Yes.
How can I write it down? I can write down x belongs to empty set, which means that equation has no solution when that fraction is equal to 0. What is the meaning of that? So, and I'm just using math symbols, and you need to see what I wrote down. What did I write down? What is the meaning in words of what I wrote down? Can you see I crossed out that symbol?
It
Yes.
doesn't belong to x-intercept.
No, it means x-intercept does not exist. Because if I don't cross, it means exist, and I crossed it out, it means does not exist. No, x-intercepts. Y-intercepts. Okay, y-intercepts. Maybe we have. Yes, we have. Really? What should we do here? We need to make x equal to 0 and plug it in. In other words, you need to find y at 0. Y at 0, is it 1 over 0 squared, which is 0, 5 times 0, which is 0, plus 6. Is it 1/6?
Yes.
Voila. Y-intercept equals 0, 1/6. Yes?
Yes.
Yes.
Because my domain is R except -2 and -3, my domain is not symmetric with, can you write this as a sentence, is not symmetric with respect to the origin. This y, this function is not even nor odd, because functions cannot be even or odd. We talked about that a lot in first chapters of our course. They maybe can be even. I say maybe. They can be even or odd only if their domains are symmetric with respect to the origin. Only even and odd functions, for sure, they have symmetric with respect to the origin domains. If they are not, so this function is neither even nor odd. I already know that its graph cannot be symmetric with respect to y-axis, or it cannot be symmetric with respect to the origin. I cannot continue further. I will dismiss you, but it is quite interesting problem, and I will definitely continue that tomorrow. Please, I will quickly check attendance, and after that, as soon as you hear your name called, because I already took care of that here, because I like to do that faster, you can leave us. So in advance of that, I am saying warm goodbye to everyone and wishing everyone a good day today. Okay, Andrew, Tima, Lorraine,
Here.
Lynn,
Here.
Juanita,
Here.
Yuran,
Here.
Gabriel, Divina, okay, Chantal,
Here.
Guangxi,
Here.
Kyle.
Here.
Kyle, thank you very much for the active participation. I hope you received my email. Did you?
Yeah, I got it.
Okay, Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro.
Here.
Thank you, guys, for being here, and everyone have a nice, beautiful day. Goodbye.
Professor.
Yeah.